So here in this problem, we need to determine the equation of a circle with the condition that it's tangent to the lines x equals to 0, y equals to 0, and x equals to a. So let's begin. We'll first try to understand this particular problem. For this, we'll go to a Cartesian system. So here in the Cartesian coordinate plane, we have the vertical line which represents the y-axis, and this is also the line x equals to 0. Even though this is the y-axis, it's representing the line x equals to 0. Then another line, the horizontal line, which is perpendicular to the y-axis, that is going to be our x-axis. And the equation of this particular line is y equals to 0. So this is our y-axis, and this is our x-axis. We have the intersection point O. Then we need to have another line which is x equals to a. So this is a positive number. So let's consider a to be lying on the positive side of the x-axis. And we'll draw a straight line that passes through the point x equals to a. So the equation of this line is going to be x equals to a. Now, we need to find out a circle which is tangent to both the line x equals to 0. So we have this line x equals to 0, the other line being y equals to 0, and the third line being x equals to a. So that means our circle will be something of this particular sort. So this is the equation of the circle that we need to obtain. However, there is one more scenario here. So the circle could lie on the downward side, that means on the negative side of the x-axis as well, and it is still going to touch the line x equals to 0, y equals to 0, and x equals to a. So that means we need to obtain the equation of these two circles. So let's begin with the upper circle. We're going to call the upper circle as 1 and the lower circle as 2. So let's start with number 1. Now, in order to find out the equation of a circle, there are two information that we need. We need the center of the circle, which is the coordinate h, k, and we need the radius of the circle as well. So let's first understand what does that signify. Whenever we have the center denoted by hk and radius r. So let us consider a circle whose center has the coordinates h, k. And if it has a radius r, then the standard form of the circle is given by this particular equation, x minus h whole squared plus y minus k whole squared equals to r squared. So that means our goal will be to find out the value of the coordinate of the center, that means the value of h and k, as well as the radius. And once we have that, we can plug it into this standard form, and that is going to give us the equation of a circle. So let's begin with a circle number 1. So what we'll do, we'll drop a perpendicular from the center to the x-axis or the line y equals to 0, and then we will drop another perpendicular from the center to the y-axis or the line x equals to 0. Our goal will be to find out the length of these two perpendicular. Now it's given here in the problem that the circle is tangent to the line x equals to a. So that means this particular length is x equals to a. Now the length x equals to a, this is also going to give us the length of the diameter of the circle. That means this particular length is also going to be a. So if this length is going to be a, that means the radius is going to be equals to a over 2. Similarly, the height, which is also the radius, its length is also going to be a over 2. Now that we have the length of the two perpendiculars, we can say that the coordinate of the center, that's going to be equals to a over 2, and the k value is also going to be a over 2. This immediately tells us that the value of h is going to be a over 2, and the value of k is going to be also a over 2. What about the radius? The radius is the half of the diameter. So the diameter is a, and the half is, we take half of it, is going to give us the radius. Now that we have the value of h, k, as well as the radius r, so our equation is going to be x minus h. So h value is a over 2. So we have x minus a over 2 whole squared. To it, we are going to add y minus k. So k value is a over 2 whole squared. And this is equals to the square of the radius, which is a over 2 whole squared. So we've obtained the equation of the circle in the standard form for region number 1, or the upper circle. However, if you want, you can further expand it, and I'm leaving that as an exercise for you to try out. Now we'll come to the lower half circle. Now here, what is going to be the center of the circle? So it's quite simple. All we have to do is drop a perpendicular and we'll see that this length, which is the radius of the circle, that's going to be a over 2, and the height is also going to be a over 2, meaning the coordinate will be it's going to be a over 2. That's the x coordinate, and the y coordinate is going to be negative a over 2. We have to be a little bit careful here. It's negative a over 2 because we're lying along the negative y axis. So that's why it's negative a over 2. The radius remains fixed at a over 2. So now that we have the center, we can say that the value of h is going to be a over 2. The value of k is going to be negative a over 2. Meaning the equation of the circle is now going to be x minus a over 2 whole squared plus y plus a over 2 whole squared, and that's equals to the square of the radius, so a over 2 whole squared. So we have found out the equation of the lower circle as well.